All right, guys, I just wanted to give you some additional help on this stuff. If you didn't do last week's assignment, some of this is going to be new and some of it not so much, but I thought it would be important to go over this. So um, I did overview videos with this in Google Classroom, but I don't know if I haven't heard, so I don't know if there's enough there. But if you went through the assignment and hopefully were able to follow along with those examples, that would help. But I thought I'd just do an additional one that's separate from the main ones for you guys. So we talked about a lot of what's in this model during our third quarter, and I wanted to just review that before we get started. So we know what an ion is, right? And we know that of the types of bonds, there's ionic bonds and there's covalent bonds. We also talked about metallic bonds. That's not part of this assignment. So if we're talking about ionic bonds, we are talking about our metals and our nonmetals. Okay, so we're talking specifically about everything from this side of the periodic table all the way over here to where the purples end, right? These guys in here are metalloids, right? We don't consider those to be metals. Remember, hydrogen is a nonmetal. It's over here because of the periodic table is arranged into columns based on the number of valence electrons. All right, so it is a nonmetal. So if I go back to the model, I have sodium and chlorine. Let's look for those guys. So sodium is here and chlorine is here. So I have a metal and a nonmetal. That tells me it's going to be an ionic bond between the two. And by definition, an ionic bond is going to be a transfer of electrons. Okay, so let's go over here, grab a pen. So here's the symbol for sodium. So the first thing we want to do with looking at any molecule is figure out the type of bond because that defines what type of molecule we have. So we have a metal and a nonmetal, so they're ionic. Okay, then we want to look at their valence electrons. Sodium is in column 1A, means it has one valence electron. Chlorine is in column 7A, which means it has 7 valence electrons. When atoms form ions or when they form molecules, they are looking to become stable. And in order to become stable, they want to have a configuration of 8, right? Or if it's hydrogen, it wants to be like helium and have 2. So hopefully that's just review. So if I have one valence electron here, and I have 7 valence electrons here, I'm forming an ionic bond. These atoms are going to be, one's going to be a cation and one's going to be an anion. So one's going to lose electrons, one's going to gain. All right. So let's just draw in my valence electrons. 1 here for sodium, 7, right, for chlorine, right? So sodium is going to transfer its electron to chlorine. When that happens, again, this is review, sodium, which has atomic number 11, which means it has 11 protons, now has one less electron than protons, which will give it a +1 charge, right? So it started with 11 positively charged protons and 11 negatively charged electrons. Now we have 10. That gives us the +1 charge. We don't write the number, we just put in the plus. Chlorine, right, has 7 valence electrons. Its atomic number is 17, which means it starts off with 17 protons and 17 electrons. It gains 1 electron from sodium. It now has 18. And it now has an overall negative charge. Okay, so I'm going to take my eraser, get rid of this arrow. Okay, take my pen. All right, so if I'm drawing the Lewis dot structure for an ion, I do these brackets, NaCl. Remember the brackets tell us that they're ions, and I include these. Okay, so that's how I got there. Hopefully that helps fill in any gaps, but we can always talk about it more. Also wanted to show you another example, and this is in the model. I'm trying to keep these videos as short as possible. I'm hoping you guys pause these as you go so you can follow along. So the other model had Ca and it had Cl. Okay, again, let's go back to our periodic table. Ca is over here, it's a metal. Cl is a nonmetal, so it's going to be an ionic bond. And the overall molecule is going to be an ionic molecule, right? How many valence electrons? Well, 2a. So calcium has 2. Chlorine has 7. All right. All right. When calcium forms an ion, it's going to lose 2 valence electrons. Sodium lost 1 valence electron. Right? So if I draw in my valence electrons here, that one goes over there. But here's the problem. We can only have 8. 8 is stable. 9 is not even possible. So what I need is another chlorine atom to come over here and take that valence electron. Okay. This allows calcium to have a +2 charge, right? Remember, you can figure out the charge from the column as well. Remember, the periodic table is our roadmap. So if it's in the second column, it's gonna have 2 valence electrons, and that's how many it's gonna lose when metals form cations. Anions, which are nonmetals, gain, right? So chlorine gains 1. Okay. So I always know that that's going to be my charge, and I always know that's going to be my negative charge. So when I draw the Lewis dot structure for this guy, I want to draw in 8 around each of these, right? And then I have to draw in my brackets, right? If we look back at the model, it's the same thing. Okay, the brackets tell us this is ionic. I know this is a little sloppy. You guys have seen me draw on a whiteboard. You know I can't do this very well anyway. All right, so there you go. I wanted to show you those examples real quick. I'm going to do one more video and walk you through covalent bonds and covalent molecules because that was on last week, so you might not have been able to follow that. All right.